All right, welcome back. So in part B, we're going to be asked to actually implement the hopping iterator, which includes determining which instance variables we want to keep track of, instantiating them in the constructor, as well as finally actually implementing the has, next, and next methods. All right, so going back to our instructions, we should probably think about what data structures we might want to use to keep track of the information that the hopping iterator would need. So first, we know that we have to have some notion of the earliest and unvisited index. And so first, tackling this issue of unvisited index, what we could do is keep a hash set or some sort of set that contains all of the indices that we've already visited. And the beautiful nature of sets is that they do not contain duplicates. And so as a result, we can easily check whether or not an index has already been visited or not. So that's going to be the first thing. All right, next, we have to have some notion of the earliest index. And again, this is the case where if the next index is either invalid or that index has already been visited. So we have to also have some notion of the earliest unvisited index. And so I'm going to call that earliest. And then finally, this is the case where the index is invalid, but in the case where the index is valid, we'll have to just simply return the value at that index. And so our third instance variable here is just going to be something called current index. So now that we have our three instance variables, let's go ahead and instantiate them in our constructor. So as I said earlier, for scene, it could be pretty much any implementation of a set. It could be a tree set, it could be a hash set. In this case, we'll use a hash set because we really have no need to maintain orderings. And then both earliest and current index are going to start at value 0. So now that we've instantiated our instance variables, let's move on to the has, next, and next method. So we'll see here that we only have one line to work with in our has, next method, so we should take a look at our data structures and determine what information could we pull from any of these that can allow us to write has, next in one line. So this comes from the realization that, well, if our scene instance variable, which is a hash set, contains all of the indices that we've yielded from our iterator, well, then we can simply use the size of that hash set to ensure that we are not yielding any more elements than we need to, and also that we are yielding enough elements. So we can simply return scene.size, and as long as it's less than the length of our input array, we know that we still have elements left to yield. Otherwise, the moment that the size of our hash set is equal to the length of the array, we know that we have no more elements left to return. All right, so next, moving on to the next method, we see here that our skeleton provides us to declare and assign this local variable answer equal to something, and we're ultimately going to return it. So this tells us that we're just going to index into array using that current index. And also, that also tells us that by the end of this next method call, current index should be updated to whatever the accurate next value should be. In addition to yielding that element, we should also add that index to our hash set. Then we'll see here that we have an if-else case, which corresponds directly to our cases up here, where either the index is valid and it hasn't been visited, or the index is invalid or has already been visited. So let's put in the if condition what a valid next index would be. And keep in mind that the next potential index will be this int answer, which is the value of the current index, and again, the potential value of the next index. So first we have to make sure that it's a valid index, which means that it has to be greater than or equal to 0. And also, it also has to be less than array.length to make sure we're not going out of bounds. And the final conditional here is, in order for answer to be a valid next index, scene cannot already contain that index. So not scene dot contains answer. And as long as all three of these conditions are met, we can simply assign current index equal to the answer. So now let's consider the case where answer is either out of bounds or scene already does contain answer. This is where our earliest instance variable will come in handy, where while earliest, while scene dot contains earliest, which means that we've already visited that particular index, and while earliest is less than array.length, we're going to increment earliest. So again, we want to increment earliest until we find an index which corresponds to earliest that we have not visited yet. And then finally, once we've exited this while loop, we can simply set current index equal to earliest. And so this is the implementation of the next method and the hasNext method for the iterator, hopping iterator class.